Hi friends, in this video, we are going to see the JEE main previous year questions from the topic Laws of Chemical Combinations and Mole Concept. Let's get started. The first question is, the candela is the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency A into 10 power 12 Hz. First, what is luminous intensity? Luminous intensity measures the brightness of light emitted in a specific direction, and candela is the SI unit of luminous intensity. Now we have to define one candela. One candela is the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 540 into 10 power 12 Hz. This 540 into 10 power 12 Hz is related to greenish yellow light. At this part, our human eye is most sensitive and it links the unit to our perception of brightness. So in this question, A is 540. So the frequency is 540 into 10 power 12 Hz. Now we will go to the next part of the question. It has a radiant intensity in the direction of 1 by B watt per steradian. Now what is radiant intensity? Radiant intensity measures the total power of a radiation in terms of watt. Now we already mentioned one candela. One candela is the intensity of a source that emits monochromatic radiation of frequency 540 into 10 power 12 Hz. Now at this peak sensitivity, our human eye perceives 1 watt of light power of 683 lumens. This 683 lumens is the maximum theoretical output achieved by perfectly efficient source emitting monochromatic greenish yellow light at 540 into 10 power 12 Hz. Now we have to convert this one candela into watt per steradian. So here the formula used is watt per steradian is equal to candela divided by 683. So here we already have the candela value as 1. So watt per steradian is equal to 1 divided by 683. So in here 1 by B is given. So here the B value is 683. B is equal to 683. So the correct option is option B, in which A value is 540 and B value is 683. The next question is, the incorrect postulates of Dalton's atomic theory are. The first statement is, atoms of different elements differ in mass. This first statement is correct. Let us consider different elements. Hydrogen is having the atomic mass 1U and oxygen is having the atomic mass 16U. Different elements have different mass. So the first statement is correct. The second statement is, matter consists of divisible atoms. Here the word divisible is given. This statement is wrong because the actual statement is, all matter is made up of tiny indivisible atoms. So according to Dalton, matter consists of indivisible atoms. So the second statement is wrong. Then going to the third statement, compounds are formed when atoms of different element combine in a fixed ratio. This third statement is correct. Let us consider the example of H2O. Here, 2 hydrogen atoms combine with 1 oxygen atom to form the water molecule. So the different elements combine in a whole number ratio, and this ratio is always fixed. So only water molecule will have the specific property. Going to the fourth statement, all the atoms of a given element have different properties including mass. This statement is wrong. Here given element refers as same element. So if we consider the element argon, all the atoms of argon will have the same mass. So for a given element, all the atoms will have the same mass and the same properties. So the statement 4 is also wrong. Chemical reactions involve reorganization of atoms. The statement E is correct. For example, consider the reaction H2 plus F2 gives HF. So to balance the reaction, in product side you have to write 2HF. Here in the reactant side, 2 hydrogen atoms are combined to form hydrogen molecule and 2 fluorine atoms are combined. But in product side, there is a reorganization of atom to form a new compound, HF. So here, no atom is either created or destroyed. No atom is created and no atom is destroyed in this reaction. So there is only reorganization of atoms. So which of the statements are incorrect? Statement B and D. Both the statements are incorrect. So the correct option is option D. The next question is, choose the incorrect statement about Dalton's atomic theory. First statement, compounds are formed when atoms of different elements combine in any ratio. Here the word any ratio is given. So this statement is wrong because elements combine in fixed ratio. In previous question itself, we saw the example of water molecule. Here, two atoms of hydrogen combine with one atom of oxygen to form the H2O molecule. So this ratio is always fixed. Now going to the second statement, already we got the answer. A is the correct option. Let us see the remaining options also. All the atoms of a given element have identical properties including identical mass. This statement is correct. For example, if you take hydrogen element, all the atoms of hydrogen element will have the identical mass and identical property. Matter consists of indivisible atom. This statement is also correct. And chemical reaction involve reorganization of atom. This statement is also correct, for which we saw example in the previous question. So the question is, you have to find the incorrect statement. So the incorrect statement is option A. The next question is, 0.05 centimeter thick coating of silver is deposited on a plate of 0.05 meter square area. The number of silver atoms deposited on plate are dash into 10 power 23. In this question, they are asking us to find the number of silver atoms. To find the number of silver atom, that is, to find the number of atoms, you have to know the number of moles. The number of moles should be multiplied by the Avogadro number. Now, to find the number of moles, the formula is given mass divided by molar mass. So, molar mass is already mentioned in question. You have to find the given mass, that is the calculated mass. So, in question, an extra information is given, density. Density is also given. So, we know the formula of density. Density is equal to mass by volume. With this formula, we can find the value of mass. Mass will be equal to density into volume. For this, first you have to know the volume. Volume is equal to area multiplied by thickness. So in question itself, area is mentioned as 0.05 meter square. 0.05 meter square you have to convert into centimeter square. So it will be equal to 0.05 into 10 power 4 centimeter square. Then thickness is mentioned as 0.05 centimeter. So when you multiply this 0.05 you can write as 5 into 10 power minus 2. Then another one 0.05 is also there. That one also you can write as 5 into 10 power minus 2. And in this calculation 10 power 4 is also there. So all the power will be cancelled and centimeter cube is there. So volume equal to 5 into 5, 25 centimeter cube. So in this case, the powers are getting cancelled. So we got the volume. So we have to find mass. Mass equal to density is given in question 7.9 multiplied by volume, which we found now, into 25. So here the value we will get as 197.5 gram. So this is the mass of silver present in that plate. Now our next work is to find the number of moles. So number of moles is given mass by molar mass. Given mass is the mass which we found now, 197.5 gram divided by molar mass. Molar mass of silver is 108 gram. So whole divided by 108 gram. So here the answer is 1.828 mole. So this is the number of moles of silver present in that plate. Now the question is, you have to find the number of silver atom. So first itself we have mentioned that number of atoms is equal to number of moles into Avogadro number. So number of atoms equal to number of moles is 1.828 into Avogadro number is 6.023 into 10 power 23. So here you will get the answer as, I will write the answer here, number of atoms is equal to 11.008 into 10 power 23. So our answer is 11.008 into 10 power 23. The next question is, the number of molecules and moles in 2.837 liters O2 at STP. Here, number of molecules and the number of moles to be found. First, you have to find the number of moles, then only you can find the number of molecules. As we saw in previous question, number of atoms or number of molecules can be found only when we find the number of moles, because the formula of number of molecules is equal to number of moles into Avogadro number. So first we have to find the number of moles. In previous question, we used the formula of number of moles as given mass by molar mass. Now we are going to use the formula given volume divided by molar volume. So given volume is the volume that is mentioned in the question. So in this case, the volume mentioned is 2.8375 liters. Now we have to find the molar volume. Here the condition mentioned is STP. STP refers to standard temperature and pressure. So here the temperature is taken as 0 degrees Celsius and pressure is taken as 1 bar pressure. So at 0 degrees Celsius and 1 bar pressure, 1 mole of a gas occupies 22.7 liters of volume. So this 22.7 liter is considered as the molar volume at this STP condition. So molar volume should be taken as 22.7. So here we get the number of moles value when we calculate as 0.125. Now with this value we can find the number of molecules. So number of molecules is equal to 0.125 into Avogadro number, that is 6.023 into 10 power 23. Here we will get the answer as 0.7528 into 10 power 23. Now you have to bring the decimal point after 7. So the answer will become 7.528 into 10 power 22. So here the number of molecules is 7.528 into 10 power 22 and the number of moles is 0.125. So the correct option is option D. The next question is match list 1 with list 2. In list 1, the first option is 16 gram of CH4. So here the weight is already mentioned as 16 gram. In list 2, first option is given as weighs 28 gram. This can be ruled out because already the weight is mentioned as 16 gram. So we can also rule out the option 3 because here also it is given as weighs 32 gram. Now what is this 16 gram of CH4? If we take one molecule of CH4 and calculate the weight, carbon is having the atomic mass 12 and hydrogen is having the atomic mass 1 and 4 atoms are there. So 12 plus 4, we will get the answer as 16U. Now if we take the 1 mole of CH4, which will be having Avogadro number of molecules of CH4, then the weight will be 16 gram. So 1 mole of CH4 is having 16 gram of weight. So in this option A, 16 gram of CH4 is mentioned. So we can consider this as 1 mole of CH4. Now, if we compare the option 2 with option 4 tells that occupies 11.4 liter volume at STP. But we already saw that 1 mole of any gas at STP occupies 22.7 liters and not 11.4 liters. So the option 4 is also ruled out. Now, only the option 2 is left. So if we see the option 2, electrons are mentioned. So we have to calculate the number of electrons. In methane molecule, carbon contributes 6 electrons and each hydrogen atom contributes 1 electron. So totally 4 electrons. So in one molecule, 10 electrons are involved. Now if I take 1 mole of CH4, we are having Avogadro number of molecules and each molecule is contributing 10 electron. So we can write as 6.023 into 10 power 23 multiplied by 10. Now if I calculate the total number of electrons contributed by 1 mole of CH4, we multiply the 10 with this 6.023 and we will get 60.23 into 10 power 23 electrons. So for option A, the correct pair is the statement 2. So for A, it is 2. Now we will go to the next one. The B option tells that 1 gram of H2. H2 is having 2 hydrogen atoms, so it will be having the mass of 2 gram. But here it is mentioned as 1 gram of H2. So 2 gram of H2 can be considered as 1 mole and 1 gram of H2 should be considered as 0.5 mole. So we know that 1 mole of any gas occupies 22.7 liters at STP. Here 0.5 moles is present. 0.5 mole of H2 gas is present. So it is going to occupy 1 by 2 of 22.7 liters. So the answer is 11.35 liters of volume. So we can round off that value to 11.4 liters. So for option B, the correct pair is this fourth one. So for B, it is fourth one. Then going to the next statement C. 1 mole of N2. So N2 is having 2 nitrogen atom. So the mass is 2 into 14 gram. So which is equal to 28 gram. So 1 mole of N2 occupies, that is, it has the weight of 28 gram. So for C, the option is 1. Then the last one, 0.5 mole of SO2. SO2 is having the mass of, sulfur is having the mass 32, plus 2 oxygen atoms are there. For 1 oxygen atom, it is 16. So 2 into 16, 32 plus 32 is equal to 64 gram. So 1 mole of SO2 has the weight of 64 gram. Here it is mentioned as 0.5 mole of SO2. So it will be having the weight of 32 gram. So for option D, it is 3. So I will write all the options here. A2, B4, C1 and D3. So out of all the 4 options, the correct option in which A2, B4, C1, D3 is there is option D. So the correct option is option D. The next question is, in the given reaction, X plus Y plus 3Z gives XYZ3. If 1 mole of each of X and Y react with 0.05 mole of Z gives compound XYZ3, then their atomic masses are mentioned. The question they are asking us is, the yield of XYZ3 is. So here, the yield refers to the mass of XYZ3 produced in that reaction. So the reaction given is X plus Y plus 3Z. So in this case, the initial moles given in that question is 1 mole of X and 1 mole of Y reacts with 0.05 moles of Z. Now, the stoichiometric coefficient from the given reaction, given equation is 1 mole of X, 1 mole of Y and 3 mole of Z is reacting. So you have to write 3. Now you have to find the limiting reagent in this equation. To find the limiting reagent, divide the initial moles by the coefficient. So here you will get 1. In this case also you will get 1. Here, if you divide 0.05 by 3, you will get 0.0167. So here Z is having the least value. So we can tell that Z is the limiting reagent. So the yield of the product is always controlled by the limiting reagent. So from this equation, what we can conclude? So the given equation is X plus Y plus 3Z gives XYZ3. Here, the limiting reagent is Z and it is having 3 moles. So we can write that 3 moles of Z is giving, here the number of moles of XYZ3 is 1. 1 mole of XYZ3. This is according to the equation. Now the initial mole of Z is 0.05. So therefore, 3 moles of Z gives 1 mole of XYZ3. Now 0.05 moles of Z will give how many moles of XYZ3? So you have to find the number of moles of XYZ3 by cross multiplication method. So number of moles of XYZ3 is equal to, when you cross multiply, you will get 1 into 0.05 divided by 3 and you will get the answer as 0.0167 moles of XYZ3. Now in question they are asking the mass. We know the number of moles formula as number of moles is equal to given mass divided by molar mass. In this question, given mass refers to the yield. So given mass or taken mass, or you can say the mass which we get from the reaction. So anything can be written in the numerator, then divided by the molar mass. So first you have to find the molar mass of X, Y, Z3. It is already given. The mass of X is 10, mass of Y is 20 and mass of Z is 30, but 3 atoms are there. So 3 into 30 is 90. So the molar mass of X, Y, Z3 is 120 gram. Now we have to find the given mass. So we will just rearrange. Given mass is equal to, you have to take the molar mass to the left hand side. So number of moles multiplied by molar mass. So the number of moles we got from calculation is 0.0167 and molar mass also we have calculated as 120 gram. So when you multiply this, you will get the answer as 2.004 gram. So which we can write as 2 gram. So the answer is 2. The next question is, chlorophyll extracted from the crushed leaves was dissolved in water to make 2-liter solution of Mg of concentration 48 parts per million. The number of atoms of magnesium in this solution is X into 10 power 20 atoms. The value of X is. So in this question, you have to calculate number of atoms. The formula to find number of atoms is, you have to find number of moles N and you have to multiply that by the Avogadro number. So in this question, concentration of magnesium dissolved in water is given. So the concentration of magnesium dissolved in water is given as 48 parts per million. The formula for parts per million is mass of solute divided by mass of solution into 10 power 6. So this everything is equal to 48. Now we don't know the mass of solute. Solute in this case is magnesium and solution is, this magnesium is dissolved in water. So we know the mass of solution because in question volume of solution is given as 2 liter. 1 liter of water is approximately equal to 1 kilogram. 1 liter can be written as 1000 ml. 1000 ml is equal to 1000 grams. So in this question 2 liter is given. So 2000 ml of water is equal to 2000 gram by mass. So we have to find the mass of solute. Solute in our case is magnesium. So let us keep that as W. W divided by mass of solution we have converted as 2000 gram into 10 power 6, everything equal to 48. So with this we can find W. W is equal to 48 into 2000. This 2000 we can also write as 2 into 10 power 3, the whole divided by 10 power 6 because this 10 power 6 will go to the denominator. So you will get the mass of solute as 96, and when you cancel the power you will get into 10 power minus 3 gram. So this is the mass of solute. With mass of solute you have to find the number of moles. Number of moles is having the formula given mass divided by molar mass. In short we can represent as W divided by M. So N is equal to W by M, and we got the W value as 96 into 10 power minus 3 whole divided by the molar mass of magnesium is 24. So here the number of moles value is 0.004 moles. Now the question is you have to find the number of atoms. So already we have written that number of atoms is equal to number of moles into Avogadro number. So we already got number of moles. Therefore number of atoms is equal to number of moles is 0.004. We can write as 4 into 10 power minus 3 multiplied by Avogadro number, which is given in question as 6.02 into 10 power 23. So when you multiply this, you will get the number of atoms answer as 24.8, and if you cancel the power, that is if you subtract 10 power 23 under 10 power minus 3, you will get as 10 power 20. In this question itself it is given x into 10 power 20. So here the x value is 24.8, but in question it is mentioned as nearest integer. So we can round off this 24.8 as 25 into 10 power 20. So the number of atoms is 25 into 10 power 20 atoms. So the value of x is 25. The next question is hemoglobin contains 0.34% of iron by mass. So in first line mass percentage is given. So in the solution hemoglobin 0.34% of iron is present. So from this what we can write? In 100 grams of hemoglobin 0.34 gram of iron is present. So the first line hemoglobin contains 0.34% of iron by mass tells us that 100 gram of hemoglobin contains 0.34 gram of iron. So in question they are asking us to find the number of Fe atoms in 3.3 gram of hemoglobin. So in question they are asking us to find number of atoms. So we already saw the formula in previous sum. Number of atoms formula is number of moles multiplied by Avogadro number. So for this first you have to find the number of moles. So in this given information 100 grams of hemoglobin contains 0.34 gram of iron. In question 3.3 gram of hemoglobin is given. So therefore we can compare with the first line. 100 grams of hemoglobin contains 0.34 gram of Fe. Therefore 3.3 gram of hemoglobin contains how many grams of Fe? So just we can cross multiply and get the weight. So let us represent the weight by W. W is equal to, just by cross multiplication, 0.34 into 3.3 whole divided by 100. So let us just keep this. So the mass of Fe in 3.3 gram of hemoglobin is, by calculation we can get. So this is the given mass. Our next work is to find the number of moles. So we know the formula of number of moles. Number of moles equal to given mass by molar mass. So the given mass is 0.34 into 3.3 whole divided by 100. Now the molar mass of iron is given as 56 U. So this is the atomic mass. Now we can find the molar mass, that is 56 gram. So this is the number of moles of Fe atom. So if we rearrange this, we will get that in numerator 0.34 into 3.3 whole divided by 100 into this 56 will go to the denominator into 56. So here you will get the answer as 0.0002 moles. Now with this number of moles you can find the number of atoms. So the number of Fe atoms is equal to number of moles is 0.0002 into Avogadro number you should take as 6.02 into 10 power 23. So here you will get the answer as 0.001204 into 10 power 23. Now you have to bring the decimal point after 1. So if you move the decimal point after 3 places, you will get the answer as 1.204 into 10 power 20 atoms. So this is the answer. So you have to check the correct option. Only in option C, you are having 1.21 into 10 power 20 atoms. So option C is the correct answer. The next question is, 56 liters of nitrogen gas is mixed with the excess of hydrogen gas and it is found that 20 liters of ammonia gas is produced. The volume of unused nitrogen gas is found to be dash liter. So you know the synthesis of ammonia equation, N2 plus 3H2 gives 2NH3. So from this balanced equation, you can see the number of moles. 1 mole of N2 gives 2 moles of ammonia. Now in question, 56 liters of nitrogen gas is given. So this is the available volume. Available volume of N2 is 56 liter. So this is the initial state. We know that initially only reactants are present and products are not even formed. So ammonia is not present initially. So in question they are telling that after the reaction completed, 20 liter of ammonia is formed. So this is the final volume. Final volume, 20 liters of ammonia is formed. And how much liters or how much volume of N2 is remaining? You have to find that. So for this, we can use the stoichiometric coefficient. So from the stoichiometric coefficient, if we tell in terms of volume, N2, 1 liter is used. 1 liter of N2 gas gives 2 liters of NH3. Then how many liters of N2 will give? In product we are having 20 liters, no? So we are going to equate with that. How many liters of N2 will give? 20 liters of NH3. So as you can clearly see, the volume is doubled in the product. 1 liter of N2 gives 2 liters of NH3. Then it is obvious that 10 liters of N2 is going to give 20 liters of NH3. So here the volume used for the nitrogen gas here is 10 liter. So the volume used for nitrogen is 10 liter. Now in question they are asking the volume of unused nitrogen gas is found to be. So to find the unused volume of nitrogen, just we can subtract the available volume and the used volume. So the available volume is 56 liter and the used volume is 10 liter. So 56 minus 10, so the unused volume is 46 liter. So the answer is 46 liters. The next question is, two elements A and B which form 0.15 moles of A to B and AB3 type compounds. So in this question, the number of moles of A to B and AB3 formed is same. It is equal to 0.15 moles. If both A to B and AB3 weight equally, then the atomic weight of A is dash times of atomic weight of B. So according to the question, the number of moles of A to B, number of moles of A to B is equal to number of moles of AB3 and their number of moles equal to 0.15 moles. Now we know the number of moles formula, N equal to given mass by the molar mass. But we don't know the molar mass of A to B and AB3. So let us assume the molar mass of A is equal to small a and the molar mass of B is equal to small b. So now we are going to write the number of moles of A to B given mass by molar mass of A to B. 2 A atoms are there. So 2 into small a and 1 B atom is there. So plus small b. Now this is equal to number of moles of AB3. Given mass of AB3 divided by 1 A atom is there. So small a plus 3 B atoms are there. So 3 into small b. Now why we have written W on both sides is because in question itself it is mentioned that both A2B and AB3 weight equally. So their weight is represented as W and they are equal. So the numerator is equal. So we can equate the denominator. 2A plus B is equal to A plus 3B. Now we are going to bring the A to the left hand side and B to the right hand side. So 2A minus A is equal to 3B minus B. So A is equal to 2B. So the mass of A is 2 times the mass of B. So the atomic weight of A is 2 times the atomic weight of B. The next question is, a commercially sold concentrated HCl is 35% HCl by mass. So from the first statement, we can tell that 100 gram of HCl solution contains 35 gram of HCl by mass. So in first statement, the commercially sold concentrated HCl is given. So 100 gram of this commercially sold concentrated HCl solution is going to have 35 gram of HCl by mass. So only the mass percent is given as 35% HCl by mass. So the next part of the question tells that if the density of this commercial acid, so for this whole solution, density is given as 1.46 gram per milliliter. We know that density is equal to mass by volume. So here volume is not mentioned. So let us consider the volume is 1000 ml. So 1000 ml is nothing but 1 liter. Now in this question what they are asking us to find? The molarity of this solution. The formula to find molarity is number of moles of solute divided by volume of solution in liters. So we have already taken the volume of solution in liter as 1 liter. So the denominator is already known as 1 liter. Now we have to find the numerator, that is the number of moles of solute. Number of moles formula is given mass by molar mass. So given mass is the mass given in question. But in question, there is no specific mass for this condition. So we have to find this given mass. First, let us find the molar mass of HCl. So the molar mass of HCl is the mass of hydrogen plus mass of chlorine. Mass of hydrogen is 1 and mass of chlorine is 35.5. So the molar mass of HCl is 36.5 gram. So the number of moles, for finding that, still we have to know the numerator. So in question, the density is given for the solution. From density, we can find the mass. We know the formula of density, mass by volume. So the mass of the solution can be found by multiplying density into volume. So the density of solution is given as 1.46 gram ml inverse. Then the volume of the solution we have considered as 1000 ml. So here you will get the answer as 1460 gram. So this is the mass of the solution. Now already in question it is given that 100 grams of HCl solution contains 35 gram of HCl by mass. Now we have got 1460 gram. So we can compare this with the first equation. So in first equation we are having 100 grams of HCl solution contains 35 gram of HCl by mass. Now 1460 gram of HCl solution contains how much grams of HCl? So just we can cross multiply. So when we cross multiply, we get the mass of HCl, that is this W value. So W is equal to 35 into 1460 whole divided by 100. So after we got W, now we can find the number of moles N value. N is equal to W, that is 35 into 1460 whole divided by 100, and everything divided by molar mass. Molar mass is 36.5. So whole divided by 36.5. So when we rearrange this, we will take the 36.5 also to the denominator. So 100 into 36.5. So now after we got the number of moles, here we can find the molarity. So molarity is equal to number of moles of solute by volume of solution. Now the number of moles of the solute we already got, 35 into 1460 whole divided by 100 into 36.5. Now everything is divided by volume of the solution, that is 1 liter. So when you solve this, you will get the answer as 14 and the unit is capital M. So the correct option is option C. The next question is, the number of nitrogen atoms in 681 grams of C7H5N3O6 is x into 10 power 21. The value of x is, in this question we have to find the number of nitrogen atoms. We know the formula of number of atoms is equal to number of moles into Avogadro number. So we need to find the number of moles. Formula for finding number of moles is equal to given mass by the molar mass. So the given mass in question is 681 gram. So in numerator we have to write 681 gram. And we need to know the molar mass. So here a molecular formula is given. So let us find the molecular mass for this formula. C7H5N3O6. Mass of one carbon atom is 12. 7 atoms are there. So 12 into 7 plus 1 into 5 plus 14 into 3 plus mass of oxygen is 16 and 6 atoms are there. So if we solve this, we will get 84 plus 5 plus 42 plus 96. So if we add this, we will get 227 gram. So this is the molar mass of this compound. So in denominator, you have to write 227 gram. Now, if we divide this, we will get the number of moles as 3. So the number of moles of this compound is 3. But in question, we are asked to find the number of nitrogen atoms alone. So in this compound, 1 mole of this compound C7H5N3O6 contains how many nitrogen atoms are there? 3 nitrogen atoms are there. Therefore, 1 mole of this compound contains 3 moles of nitrogen atoms. Therefore, here we got 3 moles for this compound. Therefore, 3 moles of C7H5N3O6 contains how many moles of nitrogen atom? So if we cross multiply, we will get the answer as 3 into 3. Totally 9 moles of nitrogen atoms are present. Now we have to find the number of atoms. So number of nitrogen atoms is equal to the number of moles is 9. 9 into Avogadro number you have to use 6.02 into 10 power 23. So if we multiply this, we will get the answer as 54.18 into 10 power 23 atoms. But in question it is mentioned as x into 10 power 21. So you have to change the power in terms of 21. So if you use the 10 power 2 to move this decimal place, you will get the answer as 5418 into 10 power 21 atoms. So here the x value is 5418. The next question is the number of atoms in 8 gram of sodium is x into 10 power 23. The value of x is dash. So in this question, we have to find number of atoms of 8 gram of sodium. So we know the formula of number of atoms, number of moles into Avogadro number. And we know the formula of number of moles given mass by molar mass into Avogadro number. So in question, the given mass is 8 gram. So in numerator, you have to write 8 and the molar mass, that is the atomic mass of sodium is given as 23U. So the molar mass of sodium is 23 gram into Avogadro number should be taken as 6.02 into 10 power 23. So if you do the calculation, you will get the answer as 2.09 into 10 power 23. And here the answer should be mentioned in nearest integer. So we can round off this to 2 into 10 power 23 atoms. So here the value of x is 2. The next question is a solution of two components containing N1 moles of the first component and N2 moles of the second component is prepared. So in this solution, two components with their number of moles is mentioned. M1 and M2 are the molecular weights of component 1 and 2 respectively. So in this solution, two components are present. So for the first component, the number of moles is N1. And for the second component, the number of moles is N2. And their molecular weight is also mentioned. The molecular weight of first component is M1 and for the second component, it is M2. From this information, we can calculate the mass of each component. We know the formula of number of moles. It is given mass by molar mass. That is the mass of the component divided by molar mass of the component. So when we rearrange this formula, mass of the component is equal to number of moles into molar mass. So the mass of the first component is N1 into M1. Then the mass of the second component is N2 into M2. So from these two components, we can find the mass of the solution. As the solution is made up of these two components, mass of the total solution is N1 M1 plus N2 M2. You have to add the mass of the two components. Now, the next part of the question tells that if D is the density of the solution, So for the whole solution, density is mentioned as D. And C2 is the molarity. And x2 is the mole fraction of the second component. So in this question, an extra information is given. Mole fraction of the second component is mentioned. Now, the question they are asking is, then C2 can be expressed as. So in this question, C2 is mentioned and it is the molarity. We know the formula of molarity, number of moles of solute divided by volume of solution in liter. So as C2 is mentioned, here the solute is taken as the second component. So the number of moles of solute refers to the number of moles of the second component. Now they are telling that C2 can be expressed as. So if you see the options, molarity is expressed in terms of mole fraction, molecular weight in the first option. In second option, density is also given. So from the options, it is clear that number of moles is not at all given in the option. So we have to change the number of moles by using the extra information, that is x2 mole fraction and the density D is given. So from this we have to calculate and we have to find the expression for C2. So let us see the calculation. So I will write the calculation in the next page. So as I already told, molarity is equal to number of moles of solute divided by volume of solution in liters. So from this we can tell that the number of moles of solute is nothing but N2. But in question, volume of solution is not mentioned. So we need to find the volume of the solution. But instead of that, an extra information is given, that is density. So we know the formula of density. Density is equal to mass by volume. So we can rearrange this formula for volume. Volume is equal to mass divided by density. Now we have already found the mass of the solution. Mass of solution is N1 M1 plus N2 M2. So the numerator is N1 M1 plus N2 M2 whole divided by density. Now, as we already saw in options, N1 and N2 is not at all given in the options. So we have to convert this by using the extra information, mole fraction. So the mole fraction of the second component is given x2. We know the mole fraction formula. Mole fraction of the second component is equal to number of moles of the second component divided by total number of moles. So with this formula, we can rearrange for N1. Then we can substitute that in place of this N1 which is present in mass. So if we rearrange this by taking the denominator to the left hand side, we will get N1 plus N2 is equal to N2 divided by x2. Now we will take this N2 to the right hand side. So we will get the value for N1. N2 divided by x2 minus N2. Now after taking LCM, N1 is equal to N2 minus N2 x2 whole divided by x2. So this is the value of N1 we are going to substitute. So we will see the substitution here. Volume is equal to, in place of N1, we are going to substitute here N2 minus N2 x2 whole divided by x2, and then we are having M1 plus the second term N2 M2, and everything is divided by D. Now we are going to multiply this M1 to this two terms, and then we have to take the LCM for the numerator. So we will see that. So the numerator becomes volume equal to N2 M1 minus, then we have to multiply this M1 to the second term, N2 x2 M1 plus, when you take LCM, x2 should be multiplied to this term, N2 M2 x2. Now everything is divided by x2, and then we are having another denominator D. So let us write that here. So the denominator is x2D. Now if you see the numerator, in numerator there is one common term. Yes, it is N2. N2 is present in all the three terms. So volume is equal to N2 into M1 minus x2 M1 plus M2 x2. So everything is divided by x2D. So this is the formula of volume we are going to substitute in the formula of molarity. Now volume should be expressed in terms of liter. So volume should be expressed in liter. But if we see the question, density is given as gram per milliliter. So here when we find this formula, volume will be expressed in milliliter, but we have to convert this into liter. So we know that 1 milliliter is equal to 10 power minus 3 liter. So just we can multiply this term by 10 power minus 3. So just we are going to multiply by 10 power minus 3. So that's all, we got volume. So just we are going to find molarity. So already in question it is given that molarity is expressed in terms of C2, and we already told that the numerator is number of moles of solute, that is N2, and we found the volume. So here our work is to find the volume. So the numerator is nothing but N2, and everything is divided by the volume which we found. So the volume is N2 into M1 minus X2 M1 plus X2 M2 whole divided by X2D, and in denominator you are having 10 power minus 3. So if we solve this calculation, so clearly we can see that we can cancel out N2 in numerator and denominator, and this X2D is denominator of denominator, so it will become the numerator. So this X2D will go to the numerator, and then we are also having this 10 power minus 3 in denominator, which will become as 10 power 3 when it goes to the numerator. So now the final answer is X2D, and then this 10 power minus 3 when it goes to the numerator, it will become 10 power 3, which we can write as 1000. Then everything divided by, you are having M1. Then in the second and third term, X2 is common. So let us take plus X2 in common. So you have to write plus M2 first, then M2 minus M1. So this is the final answer. Let us see the options. So in numerator, you have to get X2D 1000. So out of the given options, in option C only you are having the numerator 1000D X2. Then the denominator is also correct. M1 plus X2 into M2 minus M1. So the correct option is option C. The next question is, the molarity of HNO3 in a sample which has density 1.4 gram per milliliter and mass percentage of 63% is. In this question, mass percentage is given. Mass percentage of HNO3 solution is given as 63%. From this, we can write that 100 grams of HNO3 solution contains 63 grams of HNO3 by mass. So in this statement itself, the mass of the solution as well as mass of the solute is also mentioned. In this question, they are telling us to find molarity of HNO3. We know the formula of molarity. Molarity is equal to number of moles of solute divided by volume of solution in liters. So we have to find the numerator as well as the denominator in this question. So the numerator is number of moles of solute. So here the solute is HNO3. We know the formula of number of moles. Number of moles is equal to given mass by molar mass. So number of moles of HNO3 is given mass of HNO3 from this question is 63, and molar mass of HNO3 is also 63. So 63 divided by 63 will give 1 mole. So the numerator is 1 mole. Now we have to find the denominator also, that is volume of solution. In this question, volume is not given, but instead of that, density is given as 1.4 gram per milliliter. We know the formula of density. Density is equal to mass by volume. So we can rearrange this formula for volume. Volume is equal to mass by density. So here, density refers to the density of the whole solution and mass refers to mass of the whole solution. So from the first statement itself, the mass of the solution is taken as 100 gram. So in numerator, you have to substitute 100 gram divided by the density is given as 1.4. So here we will get the density as, when you solve this, you will get as 71.4 milliliter. Why? Because density is given as gram per milliliter. So the volume also we will get in milliliter, but for molarity, volume should be in liter. So just you have to multiply the 71.4 by 10 power minus 3. So milliliter is converted to liter. So we got the numerator as 1 mole and denominator is 71.4 into 10 power minus 3. So we can find the molarity. So the numerator is 1 and the denominator is 71.4 into 10 power minus 3. Now this 10 power minus 3 will go to the numerator and it will become 10 power 3. So we can write that as 1000. 1000 divided by 71.4 and the answer is 14. When you solve this, you will get 14 and the unit is capital M. So here the answer is 14. The next question is, amongst the following statements, that which was not proposed by Dalton was. The first statement is, chemical reactions involve reorganization of atoms. These are neither created nor destroyed in a chemical reaction. The first statement is correct and it was proposed by Dalton. All the atoms of a given element have identical properties including identical mass. Atoms of different element differ in mass. The second statement is also correct. The first and second statement we already saw in previous questions. And if you see the fourth statement, matter consists of indivisible atoms. The fourth statement also is correct. Third statement is, when gases combine or reproduce in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. This statement was not proposed by Dalton. Dalton's atomic theory talks only about mass and indivisibility of atoms. Dalton's atomic theory does not talk about volume or the combination of gases in different volume. So according to Dalton, he believed that atoms combine in whole number ratio by mass, and he did not talk about volume. So the option C is correct. This statement was not proposed by Dalton. The percentage composition of carbon by mole in methane is CH4. In one molecule of methane, the total number of atoms is 5. One molecule of methane contains the total number of atoms 5. So if you consider 1 mole of methane, the total number of moles of atoms is equal to 5. And out of the total number of moles of atoms, the number of moles of carbon atoms is 1, because in CH4 molecule only 1 atom of carbon is there. So here they are asking the mole percentage of carbon is equal to number of moles of carbon atoms divided by total number of moles multiplied by 100, because percentage is asked. So the numerator is 1 divided by 5 into 100. So 100 by 5 is 20%. So the correct option is option D. 8 gram of NaOH is dissolved in 18 gram of H2O. So here the component which is present in small amount should be taken as solute. So 8 gram of NaOH is the solute and 18 gram of H2O is the solvent. So the given mass of solute should be taken as W2, as we always represent solute by the number 2, and the given mass of the solvent should be represented as W1, as we always represent solvent by the number 1. So the next part of the question is mole fraction of NaOH in solution and molality of the solution respectively are. So you have to find the mole fraction of NaOH and molality of the total solution. So we know the formula of mole fraction of the solute NaOH, so it should be represented as H2. So mole fraction is having the formula number of moles of the solute divided by total number of moles. So number of moles of NaOH divided by number of moles of NaOH plus number of moles of H2O. So for this you have to find the number of moles. So the number of moles of water molecule, that is N1, equal to given mass of water by molar mass of water. So here 1 represents the solvent, that is water. So the given mass of water is 18 and the molar mass of water is also 18. So here the number of moles N1 equal to 1. Then we will go to N2, W2 divided by M2. So W2 is given in question, given mass of NaOH is 8 divided by NaOH is having the mass 40. Molar mass of NaOH is 40. So if we cancel this, we will get 1 by 5. Let us keep that as it is. So we will substitute this in the mole fraction formula. N2 is 1 by 5 divided by N1 is 1 plus 1 by 5. So if we solve the denominator first, we will get 1 by 5 whole divided by 5 plus 1 by 5. 1 by 5 plus 6 by 5. So we can cancel the 5 and we will get 1 by 6 equal to 0.167. So the mole fraction of NaOH is 0.167. Then you have to find the molality also. So first we will check the mole fraction in the options. In option A and B, 0.2 is given, which is wrong. So the option A and B is ruled out. So you have to check from option C and D. So anyway, you have to find the molality. The formula for molality is number of moles of solute divided by mass of solvent in kilogram in kg. So here the number of moles of solute is NaOH and we have found the number of moles is 1 by 5. So the numerator is 1 by 5 and mass of solvent. So the solvent is H2O and the mass is given as 18. So 18 into, as it is given in grams, always the molality should have the mass of solvent in kilogram. So gram will be converted to kilogram by multiplying by 10 power minus 3. So if you solve this, you will get the 10 power minus 3 will go to the numerator and it will become 10 power 3, that is 1000 divided by 5 into 18. So it is 1000 divided by 90. So the answer is, if you solve this, you will get 11.11 and the unit is small m. So the correct option is option C, in which the mole fraction is 0.167 and the molality is 11.11. The amount of sugar required to prepare 2 liter of its 0.1 m aqueous solution is. In this question, amount of sugar is asked. Amount is nothing but mass. Molarity is given. So from the formula, molarity is equal to number of moles of solute divided by volume of solution in liter. So the volume of the solution is already mentioned in question, 2 liter. So the denominator is 2 liter. Now the numerator is number of moles of solute, which we don't know. And the left hand side is molarity. So molarity is also already given, 0.1 is equal to number of moles we have to find. So we don't know that. And volume of the solution in liter is given, that is 2, already given in question. So we know the number of moles formula. Number of moles is equal to given mass by molar mass. So if we substitute the given mass by molar mass, we will get the number of moles, but the given mass is the thing which we have to find. So W divided by molar mass of the compound we have to find. Here the formula is mentioned, C12H22O11. So the mass of carbon is 12 and 12 atoms are there, plus 1 into 22 plus 16 into 11. So if we solve this, we will get the answer 342 grams. So the denominator is 342. So in place of number of moles of solute, we are going to substitute this value. So let us see the molarity. 0.1 is the molarity, and in the numerator number of moles of solute is given, so that we have found out as W divided by 342 whole divided by, in denominator you are having 2. So we can rearrange this as 0.1 equal to W divided by 342 into 2. So we have to find W, that is mass, amount of sugar. So W is equal to, just we will take the 342 into 2 to the left hand side. So 0.1 into 342 into 2. So the amount of sugar is, if you multiply this, you will get 0.1 into 684. So the answer is W is equal to 68.4 gram. So the correct option is option C.